So, yesterday we went over the 4 components of climate. The 4 components of climate are temperature, precipitation, light and wind. Good. Okay, so those are the 4 components of climate. Okay, and we got almost all the way through the factors that affect climate. Okay, the number 1 factor affecting climate, latitude. How far you are from the equator, okay, is going to dictate how much, okay, the intensity and duration of the light you receive from the sun. The further away from the equator you are, the less intense and the more the duration will fluctuate with the seasons. Okay, that is the single greatest factor affecting climate. Okay, so we said that on the unit exam, I'm going to give you a question as a map of Canada. Okay, I'm going to pick a city, okay, one that's obvious, and I'm going to ask you describe what you think the climate of this place will be like. That means you have to describe its temperature, precipitation, light, and wind, okay, based on the factors you think will most affect its climate. Should latitude be one? Yeah. It doesn't matter which city in the world I would pick for a question like that. Latitude can be an answer. Latitude affects every single place. Whether you're close to the equator or far from it, that is a factor that affects your climate. So there you go, there's a freebie. Okay? Latitude is always part of that answer. Okay? Then you have to look at where is it. Okay, like if I pick Calgary, spoiler alert, not. Okay, you could say latitude. I would say presence of mountain barriers. That was one of the ones we went over because that affects our precipitation, okay, and it affects our wind because that's what builds Chinooks. Okay, latitude obviously affects our temperature and our light. Okay, and then probably altitude. We are 1,100 meters above sea level, okay, and that can affect our temperature as well as our precipitation. Everybody with me there? Okay, so that's the kind of thing I would be looking for. Okay, you tell me, here's what the weather would probably be like. Okay, temperature, precipitation, light, and wind, and here's why. And I would say list at least 3 factors. Okay, latitude is definitely one of them. Okay. All right, the last 2 factors affecting climate, okay, are the patterns of prevailing winds. Okay, most places will have a prevailing wind direction. Here, our prevailing winds are west-southwest. Okay, they come from this direction most of the time. Right? We know we're in for a change in the weather if the wind is anything other than that direction. Okay, if we're going to get a big storm in the winter, it's probably a northeasterly wind that's going to bring all of that cold air. Okay, so here's kind of what happens, and this is why patterns of prevailing winds and centers of high and low pressure go together. Most of the time your wind will come from one direction. Centers of high and low pressure can affect wind direction. It can change it from what's prevailing to something that is fleeting or temporary. Okay. So most of the time, right here over Nunavut, okay, is what we call the Siberian high. Okay? It is almost always high pressure over that area. Okay? High pressure means clear skies, okay, and basically then no precipitation. So high pressure generally means clear sky, no precipitation. Okay? Dry air. Right here, where Prince George, BC is what we call the mother low. Okay? It's almost always low pressure there. That's why Prince George is by far the wettest place in Canada. Okay, and I mean by far, I mean that. It's like several hundred millimeters wetter, okay, than the next wettest place. Okay? It gets rain every day. It's like Seattle. Okay, go there if you want to be a depressed rock star. Okay, because that's the kind of weather you will get. Okay, it's going to be rainy and cloudy all the time. All right, so here's what happens with high and low pressure areas. Air rotates a certain direction around a high pressure area and around a low pressure, and it's opposite. Okay, remembering correctly, around a high, it's counterclockwise. Okay, so air rotates around the high counterclockwise. Around the low, clockwise. Okay, so what happens is periodically air masses will be thrown off of these high and low pressure areas. Okay, so what will happen sometimes is a high pressure area containing cold, dry air will get thrown off of the high pressure area, and it'll head right down Highway 2. All right? If that happens at the same time as a warm, moisture-laden air mass gets thrown off of the low pressure area, the two will interact right down Highway 2. Okay? In the wintertime, this is what causes one of those huge storms where we get 20 centimeters of snow, and you guys don't have to come to school, but I do, okay? And yeah, the buses don't run. Okay? It's because warm, moist air meets cold, dry air. But look what direction the wind will come from that day. Not from its usual direction. Okay, so if we don't get prevailing wind, something's going to happen weather-wise. There's going to be a change in the weather. Okay, if this happens in the summertime, then typically we'll get kind of a rainier period of time or high humidity and unstable weather because of thunderstorms and things like that. Okay, everybody with me on that? Okay, so these air masses, or these high and low pressure areas, generally stay put, but other ones can move in and they can alter the weather. Okay? All right. So those are your 7 factors affecting climate. So I give you a city, pick 3 of them. Latitude is 1. Okay, no matter what, latitude is 1. And then tell me how that's going to affect the temperature, precipitation, light, and wind for this city that I select. All right, climate graphs. How many people have seen one of these before? Okay, we use them actually quite a bit. Okay, if you're ever thinking of like traveling somewhere, okay, it's always a good idea to look at a climate graph, especially if you're not bound to a certain month of the year. Okay, you can kind of look at this and go, oh, I'd really like to go there in this month because the weather will be really nice typically. Okay, so what a climate graph shows you is basically just 2 things. It shows you the precipitation by month, those are the bars, and the temperature by month, that's the green line. Okay, on any climate graph, the line is temperature, the bars are precipitation. Okay, so what you'll be expected to do is be able to interpret a climate graph. Be able to look at it and go, okay, this place is obviously very dry, and this place is obviously very cold. Okay, and looking at the temperatures and precipitation is probably pretty far from the equator. Okay, things like that. Like you'll have to make some inferences based on your interpretation of the graph.
So the bars are the temperature?
No, the bars are the precipitation, the line is the temperature. Okay, so it'll have a y-axis on both sides. Okay, so the line's always temperature, bars are always precipitation. Okay, so this first place here is Manokwari, New Guinea. That city basically sits on the equator. Okay, what do you notice about the temperature? It's consistent. That you would see for basically any equatorial city, okay, or area. If anywhere near the equator, the temperature line is going to be flat. Okay, because near the equator, does your intensity and duration of sunshine change? No, right? The Earth can tilt back and forth, back and forth. If you're near the equator, that doesn't affect you very much. If you're at the poles, it affects you a lot. Okay, that's why we get summer and winter. Okay, but near the equator, no. Okay? It doesn't change your intensity and duration of sunlight. Okay, people near the equator think it does, but it doesn't. Okay, I just remember this conversation I had with a hotel clerk in Hawaii, and she was telling me, she was complaining, it was August, and she's like, oh, the days are getting so short. And I literally did that to her. What? Are you kidding me? Like, she's like, yeah, like we're down to, it's only 11 hours and, 11 and a half hours of sunshine. Poor you. Come to Canada in December and talk about short days. You don't know what you're talking about. Okay? The days just don't change very much because you're so close to the equator. Okay? It just doesn't affect your length of day. Like for a place like Hawaii, their shortest day of the year might be 11 hours. Okay? But their longest day of the year is 13 hours. Okay? It just doesn't fluctuate like it does here. Okay? We're coming up on the longest day. Right? On June 21st, we will get 18¼ hours of sunshine. Okay? It's like my second favorite day of the year. Okay? Because I can get up at 4 a.m. and go fishing until 11 o'clock at night. And it'll be sunny the whole time. Simple things and use us old people. Okay? Yeah. All right. So for this place here, definitely near the equator. Temperature stays about 26 degrees all year long. Now, what do we notice about the precipitation? High or low? Yeah, pretty high. Their driest month, okay, they still get, this is in centimeters, okay, they still get 11 centimeters of rain, okay, in their wettest month. In our wettest month, or sorry, in the driest month, sorry, in our wettest month, we get about 7 centimeters of rain. Okay, June is our wettest month. We get about 70 millimeters of rain in June typically, because that's when our thunderstorms start. Okay. All right, so this place, obviously pretty wet. Their wettest month, they get 33 centimeters of rain. Would this be a pretty tropical rainforest kind of place? Yeah, definitely. Okay, this is not an equatorial desert. Okay, if it was an equatorial desert, if this was the climate graph for Dubai, okay, would the temperature line still be flat? Might be a little higher though, right? Like in Dubai, it's over 30 most days. Okay, so the temperature line would still be flat, but it would be higher. What would the precipitation bars look like? Yeah, really low. In fact, probably a lot of months there wouldn't even be a bar. Okay? There are a lot of months in Dubai where they don't get a drop of rain. Okay? So those are the kinds of interpretations you'll be asked to make. Look at a climate graph, and from that tell me which biome it would fit with. We're going to go over biomes later, but you kind of covered those in junior high science. Okay? So would it be a tropical rainforest? Would it be a desert? Would it be a prairie, or would it be a boreal forest, or those kind of things, like be able to interpret it at least that much. Okay, next one here, this is for Nashville, Tennessee. Okay, so that's in the Midwest, so we're talking about halfway up north-south of the United States. Okay, so quite a bit lower latitude than we are. All right, but look at the temperature line. Okay, makes this kind of a curve. Okay, do they get seasons in Nashville? The temperature line would say yes, they do. Okay? If you see a temperature line and it makes a bell curve, then they're far enough from the equator that they get seasons, that their length of day and intensity of sunlight is going to change throughout the year. Okay? Now, in Nashville, it's pretty mild. In the winter, it's still above 0. Okay? Their coldest months are about 6 degrees Celsius, and their hottest month is like 28. I mean, the summertime is hot and humid there. It's pretty miserable, actually. Okay, what do you notice about the rainfall? It's lower, but is it even? Okay, even rainfall usually produces forests. Okay, so this would be like a deciduous forest, so there'd be like oak trees, hickory trees, okay, deciduous trees that would lose their leaves because there's distinct seasons here. Okay, so whenever you see kind of even rainfall, that's significant. This is still, we're talking 12 centimeters in the, or 13 centimeters in the wettest month, and still a little over 6 in the driest. That's still pretty good rainfall. Okay, here this would be like in the tropical rainforest. This would be their wet season, and this would be their dry season. Okay, they actually call them that, even though this would cause flooding here. Okay? Their dry season is less rainfall than the wet season. Okay, next one over. Anchorage, Alaska. Still got that bell curve, right? If you didn't know where these were from, could you still tell that the one for Anchorage is further north than the one for Nashville? How can you tell? Well, yeah, it's drier, but what do you notice about the temperature? colder. Same shape, still seasons, okay? As soon as you're getting away from the equator, you're gonna get that shape. All that happens to that shape is it moves up or down, okay? The further away from the equator you go, the further down this bell curve will go, okay? It'll just get lower and lower because it'll get colder and colder. Anchorage is actually one of the most mild places in Alaska, okay? It actually only, gets down to about -10 or so in the wintertime because it's near the ocean, okay? Which was a factor affecting climate from yesterday. Okay, so that really regulates its climate and doesn't make it as cold as like Denali. Okay, and you can see, yeah, there's some rainfall, but look when it is. It's actually more towards the fall. And given the temperature when that's falling, is it falling as rain or snow? Probably as snow. Okay, those are the things you'd have to interpret from the graph. Okay, oh, most of the precipitation happens in these months. Look at the temperature. Okay, the temperature is around 0, so probably that's looking at wet snow. Okay, those are the kind of interpretations you guessed. Making sense? Okay, now that you've kind of seen that interpretation, is that very hard? Okay, as long as you know the bars are precipitation and the line is temperature, those are conclusions you can draw. Okay. Looking at this climate graph, okay, near the equator or far away? Yeah, pretty far away, all right? How do we know that? Well, it's got a bell curve, right? The temperature line is a bell curve. In the summer, warmest months, we're looking at between 15 and 20, okay? Coldest months, -10 or maybe even a little lower. Okay, and look at the precipitation. Okay, so precipitation, we're talking 10 millimeters here. Wettest month is June, 80 millimeters of rain. Okay, July's second wettest, just over 70 millimeters of rain. Okay, some decent rain in May as well. Okay, and I'm saying these are all rainy months because the temperature is above 0. Okay, but here in these months, the temperature would more likely fall, or the precipitation, sorry, would more likely fall as snow. Okay, where do you think this would be? Is this enough rain to keep a forest? It's not level, right? To keep a forest, you need steady rainfall. Forests don't do well with long periods of drought, okay? This has periods of drought. Remember, snow might count as precipitation, but it doesn't count as moisture because snow is dry. Okay, I know that sounds weird, but snow, when it falls on the ground, doesn't do plants any good. Okay? It's frozen. They can't absorb it. Okay? All right, where do you think it is? So it's not a forested area. Okay, I'd say like Moose Jaw and Saskatoon would probably look somewhat like this, but go a little west of there. That's here. Okay, remember I said a few minutes ago, hey, our wettest month is June. That's when we get all of our thunderstorms. Hey, the wettest month in New Guinea is the same as the driest month in New Guinea, same as here. Okay, this is the climate graph for Calgary. Prairies or grasslands always have this shape. Okay, grasslands are going to have a bell curve because they're far from the equator, and they're going to have a period of like wet in the summer, early summer typically, a drier fall, right, and then a winter where there's precipitation but not a lot. Okay, that's typical of a grassland biome. Okay, so yeah, like Saskatoon, Saskatchewan was a pretty good guess. Those would be pretty similar, maybe a little drier. Okay, everybody with me there? Okay. Colder or warmer than the last one? Colder, okay? Now, here's something important about the precipitation bars. Look at the scale. okay? These bars look really tall, but the tallest one is only 40 millimeters, okay? That's about that much, okay? That's half of the wettest month in Calgary. So is this place drier, okay? Colder and drier. Where? Further north than here? Okay? What could be a location that might look like this to be further north than here? Okay? This is a boreal forest. Okay? Boreal forests, okay? You can see that the precipitation lines, they look like they're not even, but the actual numbers are a lot closer than Calgary's are. Okay? Calgary's driest month is less than half of its wettest. These are closer, okay? And they're lower. Boreal forests tend to be drier. That's why there's so many forest fires, okay? And, okay, they're often a lot colder as well. You can see that the warmest month is, less than 15 degrees. Coldest months are much colder. Okay? Kind of getting the idea here? Does this place look really wet? Is it? Look at the scale. Okay, that tall bar represents this much rain. Okay, is this place warm or cold? Warm. Yeah, temperature never drops below 10 degrees. Okay, is it close to the equator or further away? Still further away. How can we tell? Curve, right? Okay, there's seasons here, right? It's far enough away from the equator that intensity of sunlight is changing. But look at how hot it gets. Okay, it goes up into the 30s, almost 35 degrees. Okay, coldest month, okay, is about 10. Right? Altitude there it gives as 328 meters. Oh, I didn't put the answer on here. Okay. Any ideas? This is Mexico City. Okay. Mexico City gets seasons. Okay. They definitely have a winter and a summer. Winter's pretty mild, but they still get a winter and a summer. And it's pretty dry there. Okay. And you can see here, like there's some months where they get less than 5 millimeters of rain. That's less than half a centimeter. Okay, that's very little rain. And the wettest month is still less than 40 millimeters. Okay, so this is a desert for sure. Okay, so on this one here, they have a minimum and a maximum temperature. Let's just look at the daily minimum here. Okay, so close to the equator or far away? Close. All right. Wet or dry? Oh, well, yeah. There's a wet season for sure, and a dry season. Okay. What part of the world? Like, could you get a tropical rainforest here if you had a dry season that lasted several months? Okay. So we've already established this is close to the equator, but it's not a rainforest. But it's also not a desert, quite clearly, because the wet months are pretty wet. Australia is actually pretty dry. And Australia actually has a curve that goes the other way because it's in the southern hemisphere, right? Its bell curve is reversed. This is Africa, yeah. Well, it's not Africa, it's Manila, it's in the Philippines, but it's in that equatorial area, okay? Now, you can see here that this is looking at, okay, what we call a savanna climate, okay, or a savanna biome. There's a dry season and there's a monsoon season, okay? You get torrential rain for months, and then you get nothing for months, okay? So there's a wet season and a dry season, a monsoon season and a desert season, okay? So you don't get forests, you typically get like a tropical grassland. So it's where you'd find elephants and wildebeests and things like that. Okay. Yeah, this would be a southern hemisphere place because the bell curve is backwards. Okay, their warmest months, okay, are December and January. Right, their coldest months are July and August. So this is obviously backwards. Right. What about the rainfall? Yeah, there's a fair amount of it, and it's pretty even. Okay, any ideas? I don't think I put it on here, but this is Queensland. No, sorry, no, this is New Zealand. Sorry, this is New Zealand, it's not Australia, this is New Zealand. Okay, so where they filmed The Lord of the Rings. This is from, okay. Okay, wet season, dry season. Okay, not too cold in the winter, but there's definitely a winter, but it occurs in July and August. Okay, so this would be a southern hemisphere place. Okay, I think this one's Argentina actually. Okay. Okay, pretty even precipitation. Okay, but it's not torrential. Okay, I mean it's hundreds of millimeters for sure, but it's not like rainforest level generally. Obviously, it can't be a rainforest because it's not equatorial. Okay, if we're looking at those bars there, or sorry, the temperature line, we see it drops below 0. Okay, any guesses? So Ottawa. Okay, so expectations there pretty clear. Okay, got to be able to look at it. Okay, and then tell me. You're not going to have to give me a city. Okay, it's going to be a biome. That's as specific as I will ask you to be. Okay, so is it a tropical rainforest? Is it a desert? Is it a prairie? Is it a boreal forest? Okay, that kind of thing. That's as detailed as I'll ask you to be. And I will go over biomes before the end of the unit, and on each biome I'll show you what the climate graph looks like, so you'll have that reference. It'll be numerical response. Yeah. So still kind of multiple choice. Yeah. Okay, questions on that? All right. Okay, guys, I'm going to give you a 2-minute break here while I... Okay, so we're going to start this lesson. This lesson usually takes me more than one class period, so if we get into it today, we should be able to finish it tomorrow. Okay, and then we'll have a short lesson on Friday, because there's no quiz. Okay, we'll go over a lesson on wind patterns on Friday, which typically takes me about 50 minutes, so that works out perfect. Okay, and then next week, we'll do the math-related stuff, specific heat capacity, and latent heat. It's super easy. You don't have to manipulate anything. You just plug in numbers. Okay, and then biomes, and then you'll have your unit exam on the Thursday. On Friday of next week, we will go over that unit exam and start your final exam review, which is what we will be doing on Monday the 16th as well. Okay, so that will be the only in-class final exam review time that there will be, is whatever we get on the Friday the 13th. Okay. After we go over the Unit 4 exam, and Monday the 16th. Okay? My suggestion for you is on Monday the 16th, have studied over the weekend and come in Monday the 16th with specific questions. Because I don't have time in that 90 minutes to review the entire course, okay, or at least not do a very good job of it. So it's better if you come in and go, hey, Coder, I looked over my stuff from this year, and I'd really like to ask you a question about, mole equation, or I still don't get how to interpret this type of graph. Help me with that. Okay, that's what I want to be able to do on that 16th. Come that day, come with questions. Get your questions answered. Okay? Okay, so what we're looking at in this lesson here, guys, is energy and how it is transferred, received, etc. when it comes from the sun to the earth. Okay? The sun is by far the single greatest source of energy on earth. Okay? Everything else pales by comparison. So everything on earth is going to depend on the sun for energy. Now, lots of things can affect whether the sun's energy is A, received, and B, absorbed. Okay? So where you are on Earth obviously affects how much solar energy is received. Latitude is a factor that affects climate. Okay? If you're near the equator, you're going to get lots of sun. Directly overhead, high intensity, 12 hours a day. If you're further away, then that's going to fluctuate. But it's generally going to be less intense. Okay? Even when we're tilted towards the sun, like we are now, we're still receiving less intense sunshine than if you were at the equator. Okay? We're still far away from the equator. Okay? Even though we're tilted towards the sun, we're still not getting anything like the intensity you receive at the equator. All right, so we're going to go over the three parts of the Earth, the three things that can happen to light when it hits the Earth, and the three methods of energy transfer. So many threes. The theme is three. Okay, so energy and the environmental triad, three. Okay, everything in threes. All right. So the first thing we need to talk about is what happens to light when it gets to the Earth. The three fates of light. Okay? When light gets to the Earth, three things can happen to it. It can be absorbed. Okay? If it's absorbed, then the energy of that area will go up. Generally, that also means the temperature goes up. It could be reflected. If it's reflected, then the energy of that area doesn't change because the light just bounces off. Okay? And the last thing that can happen to it is it could be converted. Okay? What naturally occurring thing can convert solar energy into something else? Plants. Yeah. Okay? Conversion is photosynthesis. Okay? It is the one natural process that takes solar energy and turns it into chemical energy. Okay? Plants use photosynthesis to make sugar. Right? That is the start of all life on Earth. Okay? It is the one thing that can take the solar energy and turn it into something useful. Okay? All right. So that's the three fates of light. Okay? Absorption, reflection, and conversion. Okay, and we can bracket that with photosynthesis. Okay, so obviously if the area the sun hits is covered in plants, then probably a lot of the light will be converted. Okay, that's different than absorbing. Okay, absorbing means the thermal energy is taken in and the temperature goes up. Conversion means it's turned into something else. They're two separate processes. What do you suppose determines how much energy is absorbed versus how much is reflected? Okay, but plants do the conversion, right? So if it hits plants, it's getting converted. That's a separate process, right? It's one of the three fates, but it's a separate process. What determines how much is absorbed versus reflected? In the summer, what kind of colors do we typically wear? Lighter. Why? Right. Lighter colors reflect more sunlight. Darker colors absorb more. Okay? If you go out to the parking lot and there's a white car and a black car parked next to each other, okay? Go and touch them both this afternoon. Get permission. Don't touch somebody's car without permission. Okay? Like the black car will be noticeably hotter to the touch. Okay? If you have a black interior in your car, okay, it'll be hotter on a sunny day than someone who has a lighter color interior, because lighter colors reflect more light. Okay? White reflects everything. Black absorbs everything. Okay? And then there's the spectrum between white and black, okay, that is varying degrees of absorption. Okay? That spectrum, okay, between absorption and reflection is called albedo. Okay? Albedo is the reflectivity of any given surface. Okay? Low albedo, darker color, lots of absorption. Higher albedo, lighter color, more reflection. Does this kind of compound our temperature problem here? In the summertime, obviously the plants are open and green, so they're doing a lot of converting, okay? But are there generally darker colors on the ground? Right? Like the dirt's exposed. Agreed? What's the dirt covered by in the wintertime? What color is snow? Yeah. Okay, so not only are we getting way less solar radiation in the wintertime, not just duration, but also intensity, but anything we get bounces off the snow and reflects back out into space. Okay, that's why the temperature here fluctuates so wildly between summer and winter. Okay, when your ground, the thing that's supposed to be doing the absorbing, is covered in white snow, it reflects away a lot of that radiation. This is actually a huge problem for people who are like trying to preserve the glaciers, okay, in like Jasper and Banff. Okay? Recently, with all the forest fires that we've had the last few years, a lot of ash has been deposited on the glaciers, okay, making them darker. Because normally a glacier is covered in pristine white snow and ice. Okay? But the last few summers, our glaciers have retreated more, partly because during the spring, soot and ash fell on them right before the summer, okay? Lowering their albedo and making them more absorbing. Okay? And so they melted faster because they absorbed more solar energy. We use this exact same idea in the wintertime. Okay? In the wintertime, when we get a bunch of snow, what do we throw on the roads? And salt and sand. Okay? Does the sand make the snow darker? Yeah. So a combination of sand and salt on the roads lowers the melting point. The salt lowers the melting point of the snow. The sand makes the snow more absorptive because it makes it darker. Okay? So it melts faster. It's also why we make our roads dark colors. Okay? If you go to LA, they make all their roads out of concrete, much lighter in color. Okay? Any asphalt roads in a very hot area, they get soft. Because in the summertime, they absorb a ton of the heat, and all the oil and stuff that makes asphalt the way it is, okay, starts to liquefy. Right? Actually, you can see it here. We get that same problem in the summer, okay, but we kind of deal with it. But have you ever noticed that at the intersections, there's a definite groove for each tire, okay, at the intersections? Because people are sitting there, all the weight is there, right? And then if you've got, the summer months where that's getting hot, okay, it gets softer. Okay? Asphalt is actually softer, okay, in the summertime because it absorbs more of that energy. Of course, we want that in the wintertime because then the road will get warmer, okay, faster, and it'll melt the snow and ice and keep it, safer. Less ice on the road is always safer. Okay, so we use that same idea, okay, in order to help us make roads safer. Okay, we lower the albedo of something. Okay, if you want something to heat up fast, Okay, in the sun, you make it darker in color. Okay, anybody ever seen one of those like camp showers? Okay, basically it's just a black plastic bag with a hose coming out of it. Okay, you just put the black plastic bag in the sun, it heats up the water inside, and you can have a warm camp shower. Okay, because you're just using something with a low albedo. Okay, here's another one for you. I don't know if anybody's ever noticed this one. You guys have all seen this stuff before, right? You ever notice that aluminum foil has two different sides? One's dull, one's shiny. If you're doing a baked potato and you wrap the baked potato in this, which side do you want out? Shiny side's going to reflect. Which side do you want out? The dull side. Okay? I've gone to a lot of barbecues, guys. Not a lot of people know about this feature of tin foil. Okay? So when I'm watching the person prep the potatoes, okay, I chuckle to myself because they clearly have no idea. Half the potatoes are wrapped with this side out correctly. Half the potatoes are wrapped with that side out incorrectly. And I go to the person running the barbecue and I want that one, please. Because I don't want a raw potato, which is what I would get from the one wrapped this way. Because you put the reflective side out and it's just reflecting all the heat away from the potato. If you wrap it with this side out, not only does it absorb all of the heat, but after it goes through the potato, it hits the shiny side and reflects it back into the potato. That's why this stuff is designed the way it is. Okay? It's designed to cook faster by absorbing and then not letting it out. Okay? It just bounces around through the potato because it can't get back out because of the reflection. Okay? Has anyone ever seen the emergency blanket in your car? Okay? It's just made out of this. Right? It's just a foil blanket. If you put it on, which side should you face towards you? The reflective side. Okay? You want to reflect your heat. They work really well. Okay? You can, I mean, don't try with the emergency blanket because you can't put it back in the package once you take it out. Okay? But you could, like, you know, make sure no one's watching. But you could wrap yourself in tin foil. Okay? And if you wrap yourself in tin foil with the shiny side, you'll get hot. Okay? It works really well. There's no insulative value to this. Okay? It's not keeping you warm because it's got good insulation. It's just keeping you warm because it reflects your heat back at you. Okay? Lots of times when they're building like green homes, okay, the insulation will have a layer of foil on it, okay, on both sides. And that foil is designed to reflect heat away or reflect heat back in, okay, depending on which way you orient it. Okay? All of that stuff goes into making things more efficient. Okay? But it's simple energy transfer stuff that we're going to talk a lot about tomorrow in class.